Hey guys, I'm a science potato, and today we're going to be discussing how to print the COVID-19 relief ear savers for face masks as fast as possible. So I've got one of them here that I found on Thingiverse. We've printed and tested these and we know they work pretty well. So the first thing we're going to do is give it a quick slice with one of Kira's just default profiles. Not even a profile built for a specific printer. This is just the profiles that they supply with the software itself. So you can see we're getting a print time of about 20 minutes. And honestly, if you're printing huge amounts of these, which most of us are, 20 minutes is way too long of a print time. We can zoom in here, take a look, we can see it's filling all this detail in. So it'd probably be a good print, but 20 minutes is way too long. So let's see how we can cut that down. So first thing I'm going to do is switch to one of our default profiles and give a quick look as to how long this one would take. 7 minutes. That's much better. Although, if we analyze our G-code viewer here, we can see that there are a lot of gaps here, and that's not good. That's going to reduce the strength of this part, and we don't want these to fail. So while a 7-minute print time is way better than 20 minutes, this still needs some tweaking in order for it to be done well. So the first thing we're going to do is crush that print time even more. And what I like to do is up our line width. So we have large nozzles, we got 0.6, 0.8, 1 mil nozzles, so we can use larger line widths. So I'm going to start with a 0.8 mil line width. And we'll take a look at that and see what it looks like. So we shaved another minute off there, and we can see it's looking better now, although we still have a gap right here. And these tiny little gaps, kind of these voids here, we're not too concerned about. But anywhere there's a break in the line, like that break right there, we don't want that. We also do not want that break right there. So let's see what more fine-tuning we can do. One of the things is if we turn on our travel moves, we can see it's putting little dollops right in the middle of these holes. And that's adding a lot of travel time to get to each one of those dollops. So we don't really need to do that. So what we can do is reduce our infill to 0. We will also reduce our top and bottom layers to 0. It looks like combing is on here. We're just going to turn combing off as well. Alright, 5 minutes. Doing better. So you can see we've got those little holes right in the middle of those circles there, which is fine. So now those features are looking better, but we still have these little voids here. So the reason those voids are there is because the thickness of that part is not a good value for a 0.8 mil line width. So to adjust that, we're going to go to our shell. We're going to scroll down to our horizontal expansion. This is going to increase the X and Y dimensions of our part by increase or decrease them by whatever value we have set. So by default, I have it set to a negative 50 micron. So that means a cylinder would have a reduction on its diameter of 0.1 millimeters with a value like this. And that's mostly to compensate for material expansion, stuff like that. You can use this setting to fine-tune your tolerances on fine tolerance parts. But instead of a negative value, we're going to set this to a positive value. And that's going to thicken up these walls a bit, which should allow our 0.8 mil line width to fully connect all the way through. So you can see the gap here is gone. And we still have a little bit of a gap there. So maybe we'll try increasing this to 0.1. See if we can get rid of that gap. There we go. Now that gap's gone. So it looks like our print's doing pretty well now. But we're still at a 5-minute print time. That's not too bad. Way better than 20 minutes. But we still have some tweaking we can do. So one of the things I'm noticing is how thick this part is. You can see we got 1, 2, 3, 4, 5 lines and 1.5 millimeter thick part. And we've printed these parts thinner than that, so I know that they can work well. So because we're using a 0.3 millimeter layer height, I'm going to set our Z dimension to 0.9. So I'm going to turn off our scaling. We'll go 0.9. Make sure our Z is still set to 0. And we'll slice it again. Boom, now we're down to 3 minutes. That's awesome. And we could even potentially try turning this skirt off, just to see if there's a bit of print time in that skirt there. Because you wouldn't actually print one of these at a time. You'd probably print as many as you can fit on a build plate. So yeah, we're down to a 3-minute print using 2 grams of material. That's awesome. We can look at our breakdown here. See, we got 1 minute of inner walls and 1 minute of outer walls. Now, Cura doesn't go to a per second value, but yes, this is a very quick, efficient print now. Much better than 20 minutes. If you were to load up a build plate of these, like I have in the display picture I have for this video, we were able to fit about 39 of these on a build plate, and they took about a bit over 2.5 hours to print, I believe. So you can drastically reduce your print time, and if you only have a couple machines, you can drastically increase your throughput on production on these. You know, instead of making 10 a day, you can make 40 a day on a single printer. Well, that's all I have for you guys today. Thanks for watching my video. Please like and subscribe for more content. I do a lot of design commentaries. I'm also a product designer and do a lot of my own personal designs for a lot of cosplay and sci-fi stuff I'm a big fan of. So if you'd like to see more of that, please stick around for future videos. Thanks. Bye.